In this video, I will teach you about gas springs. Gas springs are very common throughout industry. You see them often in everyday life. Almost every car uses them to hold open the trunk and the hood. This type of spring is unique since it produces an almost constant force throughout its entire stroke. To help you better understand this type of spring, let's compare a gas spring with a typical wire spring. As you push on a wire spring, the resistive force increases as it compresses, so it gets harder and harder to compress the further you go. A gas spring, on the other hand, does not do that. The force remains almost constant as it compresses, which provides some very valuable benefits. Let me explain how a gas spring works. A gas spring is a piston cylinder device like this that is pressurized with nitrogen in the factory and remains pressurized throughout its life. The pressurized nitrogen pushes on this side of the piston, and if that's all it did, then it would not have a constant force since the pressure would increase as it compressed. Therefore, there is a hole in the piston which allows the pressurized nitrogen to act on this side of the piston as well. Now you may be wondering how this can possibly act like a spring and produce a net extending force since the nitrogen is pushing on both sides of the piston. But if you look carefully, you will notice that this side of the piston has a larger area, and this side has a smaller area since the rod is taking up some of the space. This difference in area produces a net extending force, which can be calculated by taking the pressure times the large area and subtracting the pressure times the small area. It is this difference between the large and small areas that results in the net extending force, which is why gas springs are always normally extended. Now some people think that once the spring is fully extended, the pressure can only act on this side, but that's not true. The nitrogen still passes through the hole in the piston, and the pressure pushes on this side as well, even though there's not much space down here. As you push the spring and cause it to compress, this nitrogen passes through the hole into this side of the device. It does this as it continues to compress until the piston can't move any further. At this point, the pressurized nitrogen is now on this side, and you may think that the pressure is now only pushing on this area. However, since there is a hole in the piston, the nitrogen pressure still gets through and pushes on this larger area as well, which is why there is still a net extending force developed. Now you may have noticed that there is slightly less volume for the nitrogen on this side of the piston than when it was extended, since the rod is taking up some of the space. And you are correct. And this does result in a slight increase in the nitrogen pressure as the gas spring compresses. And therefore the force does increase slightly as the spring compresses, which is why we said at the beginning that gas springs can be considered to have almost a constant force throughout their stroke. As a matter of fact, gas springs have a K factor, which indicates how much the force increases as it compresses. But in this video, we won't go too deep into that, and we'll just assume that gas springs have an almost constant force as they compress.